Hi, this is our copper amine synthesis lab where we will be doing 4 separate dilutions as well as making our very own stock solution in order to find an unknown. Currently, Cambry is making dilution 1 where she took 5 milliliters of the stock solution and added it to a 25 milliliter flask, where she will then add in water to the meniscus line of the 25 milliliter flask and then mix it together to get dilution 1. This is where she will now begin inverting it to make it mix together. And when she's done inverting it, that will complete dilution 1, giving us 25 milliliters of our dilution 1. Next, we will see Aaliyah making dilution 2. It is the same as dilution 1, except for instead of taking 5 milliliters of stock solution, she is taking 5 milliliters of dilution 1, adding it to the 25 milliliter flask, then adding water to the meniscus line. You have to be very careful not to go over the meniscus line. If you do, you have to start the lab over. She will invert it, and when she's done, she will pour it in the beaker, showing the completion of dilution 2.
This is Angel completing dilution 3. She's taking 5 milliliters of dilution 2 and adding water to it and filling it to the meniscus line to complete dilution 3. So, to measure the absorbance of all of our solutions, we use the spectrophotometer. An example of quantitative data that we can get from the spectrophotometer is the absorbance or transmittance values at specific wavelengths, which can then be used in Beer-Lambert's law. Qualitative data, on the other hand, is non-numerical data, and that could be, an example would be the color for the solution and where it peaks on the absorbance spectrum. You would scan across all wavelengths, 200 nanometers to 800 nanometers, in order to see what sample would absorb the most light, the shape of the spectrum, and find lambda max. And lambda max is defined as the wavelength at which absorbance is the highest. For us, it was 590 nanometers. This is now Valeria doing the 4th and final dilution. So to explain Beer-Lambert's law, it is defined as A equals ELC. A stands for the absorbance. The absorbance can be measured by the spectrophotometer when a light of a specific wavelength passes through a sample. E stands for molar absorptivity, which is determined by measuring the absorbance of known concentrations. L is a path length, and that can be known from the cuvette dimensions. And in standard spectrophotometers like ours, it would be 1.00 centimeters. Finally, C stands for concentration, and that can be determined by the concentration curve. Absorbance is directly proportional to the concentration. So, as concentration increases on the x-axis, absorbance also increases linearly on the y-axis. Failing to zero the machine with a blank would measure an absorbance value that is too high or overestimated, because the instrument would count both the analyte absorption and the background absorption, which is why it is very important to zero before placing in the spectrophotometer.